Hello there and welcome to part 1 of the modular weapon system tutorial. So I have an empty Unity project over here, pretty vacant. We're going to start right away, create a weapon folder, use it to organize everything related to the weapons. We're going to create a weapon script and open it. I'm using Visual Studio for this, obviously pretty standard. I have a custom, script creation template, so you might face some issues that I might not face because I have, some imported namespaces over here. But hopefully that shouldn't be too big of an issue for you guys. So we're gonna start this right away by basically creating our module. So the idea here is that we want a system that can give us a lot of functionality, but it can be easily extendable. So we're going to be using interfaces for two things here. Let's see. We're going to create, actually we can make it a nested sort of thing. We're going to create an interface and call it an iBehavior, and then we're going to create another interface and call it an iModule. So the idea here is that the iBehavior is going to have methods that, something like the start and the awake methods, but they're going to be controlled by the weapon, so we can control the order of execution the way we want it. So the way I'm going to use that, the way I'm going to do that is just call them something like configure for awake and void init, short for initialize. Let's do some comments. This is basically like the start function, and this is like the awake function. So what we're going to do is we're going to get every single iBehavior that is attached to the weapon and then call these methods the way we want them. Now, the other interface, the iModule, is going to basically just, we're going to set the weapon reference using it. It's sort of like a dependency injection, you can think of it like that. So set weapon and reference. So now we're going to make the base classes that we're going to use. So I'm going to create a behavior class that inherits from that iBehavior, and we're going to implement those configuration functions basically. Don't forget to make them virtual, because we're going to want to override them in the derived classes. Remove the exception handling code, and then we're going to create a module class that inherits from the behavior and implements the iModule class. So same thing again, implement the interface, make that virtual, and here we're going to make a let's make, for example, a public weapon property, but it has a protected set method, and we're going to set that weapon reference over here. So you might be able to see what I'm trying to do here now. So the idea is that these classes I can use to just inherit from, but I have that interface fallback if I want to mess around with things more, if I want to inherit any module from something that is not, one of these classes. You can just implement the interface every time, or you can just inherit from the classes. It's a little bit complicated to explain it like this, but it's you're gonna understand it next. So next up, we're gonna create the basic modules, I could say, for example. So modules. Now it's important to dissect, hold on, let me silence my phone. It's important to dissect what a weapon will do and to implement that functionality into the form of modules. The way I do it is, first of all, by implementing a weapon action module. Every weapon will have an action that it does. You know, a firearm will fire, a melee weapon will swing, or something like that. And so the way I implement this module is pretty simple: weapon.module. And this right now is basically a module of the weapon. Next up, I have a weapon constraint. And this will basically constrain the action of the weapon to only be available, you know, to only be able to do actions at certain conditions, you know. So you have a weapon that fires every 0.1 of a second. You have a weapon that fire, you know, you can't fire a weapon maybe if you're in the air, or if you have the weapon holstered and something like that. That's basically the constraint module. Weapon.module again. So pretty simple so far. So what I'm going to do is basically retrieve all of the behaviors and the modules for the weapon. So I'm going to make a behavior array, call it behaviors, and I'm gonna do the same basically for the modules, a module array, call it modules, and inside of the awake function, or we can actually make a function called set up, you know, so we can call it from other code, you know, instead of the function being called automatically if we make it an awake or a start method. So what we can do here is to get every single behavior that is attached to this weapon, and we can do that by getting components in children and limiting it to the iBehavior interface. Include children, inactive children, make that true, and weapon iBehavior. Oh, sorry, we make this an interface. Sorry, I missed that a little bit. But next up, basically the same thing. Get components in children iModule, true. And also considering that every module inherits it's going to be inheriting the iBehavior, we can just look up this this array already, considering that we have it, you know, basically look up every element in the behavior array and determine if it's a module. But for now, this will work pretty fine. So first up, we're going to be doing something like this: modules for each, or what was it called? I do have link on, right? But this is an array. Hold on. Array dot for each, then modules. We're going to do an anonymous function here to basically just set the reference, you know. Remember this function over here, this is going to be called for every single module in the array. We're going to be basically doing the same thing again for the behaviors for each behavior. There we go. We're going to start with the configure because it is like the awake method over here. Yes, the configure is like the awake method, and the initialize function is going to be the, you know, like the start method. So there we go. Now we can start implementing some sort of behaviors. So for the weapon action, I'm going to implement a function called actually, hold on. I would like to implement a update loop over here and a function called process, and then an event action called on process. And we're gonna be basically just calling this process from the update loop. The idea is that I want to control the execution of every single module right from the weapon script. So instead of having every module have its own, start and await methods and update methods, I'll just implement those methods on the weapon script and then use them from the weapon action script. So we're going to do something like this, for example, override initialize, and then weapon, that's the reference that we get from the weapon.module over here, on process, and this is basically just an update loop. We can treat it like an update loop basically. So now we're gonna want to have some input going into the action. The action is going to be controlled by player input, AI input, or something like that. And also, this is a good point to clarify here. This system is going to be usable by AI or players or any sort of thing like that. It's a sort of a general system. For now, I'm going to be focusing on making this a system usable by web players. So it's going to be controlled by mouse, keyboard, joystick, and stuff like that. So what we're gonna want to do is have the weapon action receive input from the player, but we're gonna want to do it in a sort of modular and easily, what can I say, sort of like an easily interchangeable way. So if we have AI that wants to control a weapon, we don't have to change too much about this. And the way I do this is by, surprise, surprise, using interfaces. So I create an interface, I call it a processor, an I processor, and I'd like to have this interface inherit from an interface on the weapon script. So I processor, there we go. We're gonna have this inherit from that weapon.I processor. The I processor doesn't have anything to do with the process. Those are different things. The names are somewhat similar, but different things. So the idea here is that we're going to be passing the input throughout this I processor method. So for the action or the player input that will create the weapon action, we're going to want something like a float value that showcases the the action sort of thing. So this, you can consider it like your input dot get button sort of callback. Input dot get button fire 1, something like that. In a normal system, you just do something like this. If input dot get fire button 1, then if the weapon can fire, then fire. But we're trying to do something modular here, so of course we're gonna have this I processor abstraction in the way. The reason that I make it a float is some games have like special interactions with joysticks. Destiny 2 has something like this, where if you're using a revolver and you're controlling your player using a joystick, then the revolver hairpin trigger, the movement on that will correspond to your trigger pull, and I think that's kind of a cool thing, and I want to replicate that sort of thing. So now to move forward here, we're going to have a reference to that I processor called a processor, obviously, and the idea here is that we will get that processor from the entity that owns this weapon. So if it's owned by player, then the player will implement a class using this function over here, the I processor, and then we'll get that class. So what we want here in our weapon, again, is a concept of ownership. So we're going to do something like that. We're going to make an interface, call it an I owner. This is basically just a generic method to describe the owner of a weapon. So the owner will give us a certain amount of processors that we can choose from. No need to make that public. Processors get, and we're going to implement again this interface into whatever thing that we want to control the weapon. So processors, we're going to make something like this inside of the setup function. We are going to pass in a owner, a reference, and we are going to have a variable of the type owner called owner, and we're just gonna set that reference over here. So now we're gonna make a helper function that will allow us to retrieve a certain processor, you know. So if we want this action processor, we can just call weapon.getProcessor, you know, something like this. It's going to return a generic get processor of type T, and we're going to have a little bit of a constraint on this where T is a type of processor, and we're going to be basically iterating the owner.processors array and checking if the current processor is of that type T, and if it is, we are going to return it, then return processor. And hold on, misspelled that, processor, return null if nothing is, you know, found. Or we can maybe throw an exception for this, let's say that no processor of type, and insert that type of T found, you know. So if a module is trying to get a processor from this weapon and the owner doesn't implement that processor, just throw an exception. We'll deal with it later. So the way we can use this over here is simple. Processor equals weapon.getProcessor I processor. Perfect. Now we have this processor in hand, and we can basically use it. If processor dot action is bigger than 1f, for example, or something like that. We don't need the else statement for now. But here comes the part of the other module that we have, which is the weapon constraint. We don't want our weapon to constantly do actions, right? We don't want our weapon to constantly fire every single frame. So we're gonna have some constraints going on over here. We're gonna make another interface. You can see I really love these interfaces. I'm gonna just call it the I interface. I know it's a lovely name, but it'll be a little bit more clear when you use it in other classes. And this interface is gonna be really simple. It's gonna just implement one Boolean field called constraint. And the idea is just like the way that we get every single module and behavior that is attached to the weapon, we're going to get every single constraint that is attached to the weapon again. And if this constraint field is set in any one of those modules, then this weapon cannot perform the action that it's made to do. You know, it can't fire, it can't swing. So we're going to make a public list of interfaces over here. Let's just call it a list and mistype that. Protected set. We're going to override the configuration method, and we're going to make this list an empty list, and we're just going to add range, and we're going to add every weapon behavior that implements this interface. You know, so we're going to do something like this: add range weapon.behaviors, dot what's the method name called again? Select, I think it's called. Yeah, select x is I interface. This should be it, right? Whoops, sorry, not select, where x and then dot cast that stuff to the II interface. Yep, this is it. So we're basically just we can make this a little bit more readable by doing something like this. This is the range, or we can call it the selection, and then add in that selection. So the selection is basically every weapon behavior where that weapon is this interface, implements this interface, and we're just casting that that range to the interface method, so we can just add it right in. So we are going to make a little property over here, a pull property called a constraint, or we can call it something like active. So if any one of these constraints in the list is active, this value is going to return true, and if it's not, it's going to return false. And we're going to do this by iterating every single item in that list, checking if the list dot constraint is true. We're just gonna instantly return true, and if nothing, return false. So we can check on this constraint inside of the weapon action script. And the way I like to do this is for every vital sort of module, I like to have a reference to it inside of the weapon script, the big weapon script. And let's have that reference over here, public weapon action get protected set, and then a public weapon constraint, a constraint protected set. So we're gonna set these fields over here so that we can use them from any other module really easily. And the way I'm thinking of setting these is, let's see, we can do action equals modules dot first x is weapon action as a weapon action. There are better ways to do this, but it's a one-liner and it's fast. You can care for optimization and speed in your own code. I'm just trying to give you the idea as fast as possible over here. We're going to do the same thing for the constraint. We're going to look for the first weapon constraint, cast it as such, and this way we have both of these action and constraint properties. We can also do something for like if action equals null, throw an exception and stuff like that. It will be nice to add into your own code. I'm not going to add it because it's a lot of boilerplate code. It's useful because basically every weapon should have these weapon constraint and weapon action modules, so you can think of them as requirements for for a weapon to basically function. And what we can do now is we can access that weapon constraint from inside of this weapon action class. And what I'd like to do usually, instead of typing something like weapon.constraint, is that I make an accessor for it. A really fast accessor, something like this, weapon constraint, weapon.constraint. I know it's really pity, but it makes the code a little bit neater. It's just a quick accessor to that constraint. You can also add this inside of the weapon module, if you just want that accessor for every one of these things, or you can use the code directly, weapon.constraint. But anyways, now what we're gonna do is if the weapon dot if the processor dot action is bigger than 0 of, and this is a little bit of a wrong code here, if it's bigger than 0.1 f, or let's say something like a variable, let's call it a minimum input, something like 0.1 f. Doesn't really have to be a variable, I think, but you know, it's always nice to have customization within the code. And basically this is the minimum input that if we achieve, the weapon will try to do its action. You know, again, in that joystick scenario, when you're pulling on that trigger, you're getting a linear value, a float value between 0 and 1. So this minimum input of 0.1 will mean if we just slightly pull on that trigger, the weapon will try to do its action. Next up, we're going to check if the constraint dot active. So the constraint dot active is true, we can't do the action, but if it is false, we can do this action. So what we're gonna be doing over here is making another function called perform, and this is basically the action performing, you know. So every time this function is called, a weapon is going to get fired, a club is going to get swinged, and stuff like that. We're going to make an event, an action on perform, and this will allow us to basically add in as many actions as we want pretty dynamically. So don't forget to call that function. Sorry, there we go. So pretty simple so far. If the input is bigger than the minimum input, and if no constraint is active, then we're going to perform this weapon action. Let's start off by doing one simple little action over here. Let's make a let's try to organize this first of all, sort of an action. Move that into here, wait for scripts to compile, and we're gonna make a implementations of this weapon action thing. So the most basic weapon action I can think of is a raycast action, sort of, you know. You have hit scan weapons, and you're gonna need to perform a hit scan every time the weapon fires. So we're going to make a weapon raycast action, and wait for this thing to open. There we go. As usual, we're going to start off by making this a weapon module, weapon.module. We're going to overwrite the initialize function. We're going to go weapon.action.onPerform, and then we're going to listen to that onPerform action. And you can see I didn't make a quick accessor for this. Sometimes I don't, sometimes I do. It's really not specific, but anyways, don't care too much about that. So we're going to make this weapon raycast action actually fire a raycast, and that's going to be really simple. If physics.raycast, and we're going to use one of these overloads. Yep, this one basically. So first of all, we're going to set a transform and call it the point, and this is basically going to be the point of which the raycast gets fired. So if you have something like a firearm, you're gonna want that point to be in front of the action of the gun, you know, in the barrel. Basically, you want the weapon to fire from the barrel. You can have it firing from the middle of the screen, and you know, some games do that, but basically that's going to be this, the point. I'm gonna make another variable, call it the range. This is basically just the range of the weapon. 400 meters should be sufficient for this, and we are going to need a layer mask, and you know, so we can set our weapon to not hit ourself, you know. a mask, and we can give it a default raycast layers value. It's -5 or something. Basically, it just assigns the layer to everything but the raycast layer. It's nice to have it this way. So we are going to call this function with our data. First of all, the point position is the origin, and then the point direction, point dot forward is the direction of firing this raycast. Here we go. So let me remember what this overload looked like. There we go. We're going to have a hit info go over here. The max distance is the range, the layer mask is the mask, and we don't need to override the query triggering interaction for now. So here we go. If physics.raycast, all of this stuff, then the raycast of course hit. We can debug.log wherever this thing hits. So let's debug the transform that got hit, and basically this is the first meaningful module that we have created, and we can implement it in a weapon game object. So to begin with though, I'm going to need a owner for that weapon, so more code over here. We're gonna make a player, if I can spell that correctly, there we go, player, and this player is going to be the owner of our weapon. It's going to implement that, the weapon.I owner interface, and we're going to implement that array over here, there we go. And inside of the start function of the player, we're going to get every processor, get components in children, weapon.I processor. We can set the include children to true, doesn't need to, but let's just do that. And then we're gonna want a reference to a weapon, the weapon that we're currently holding, for example, the weapon, and weapon.setup. Remember that function over there? We're going to pass in the owner of the weapon, which is this, the player, basically. So this is of course a weapon system tutorial, so the player is going to be like extremely simple stuff. It's just basically going to have like some simple movement and looking around. If you want a player tutorial, we're going to have to look somewhere else. It's we're just going to be focusing on the weapon system itself. So this over here is going to be our player, and we are going to make a weapon script over here. We're gonna add in the weapon script, add in the player script, set the reference to that weapon, and we're gonna make some modules over here. Modules relating to the weapon, of course. First of all, let's call this game object modules, and then we can create an action module and a constraint module. So a weapon, oh, actually I think I missed something over here inside of the weapon script. The I behavior does not implement mono behavior. Yes, we need these to be components, so they're going to be inheriting from the mono behavior, of course, the behavior. And then every module will inherit from that behavior, which inherits from mono behavior, so we can add it into our weapon. It's already compiled, that's good. Our weapon action, and then weapon constraint, and finally a weapon, a raycast action, something like that. We can put it right there, our weapon raycast action. For the point right now, we can just use the raycast object itself, which points forward, it's sufficient. We can then make a layer for our weapon, but that's not necessary for now. What I would like to do is to implement that processor. So the processor for the weapon action, of course, that's going to be feeding in our input, and we're going to be doing that using this weapon action.iProcessor implement interface action, and it's gonna be input.get get key code for now should be sufficient. Keycode.mouse0. We're gonna be checking if it's true, 1F, if it's 0, 0F. And the idea again behind these processors is that you can implement them in any sort of way that you want. So I can make like a player weapon action input class and use that, but for now I'm just going to be implementing it right on the player object, because again this is a weapon system tutorial, not a player system tutorial. So there we go. Now we should be able to actually do all of our raycasting, and we have a basic weapon going on. So what I'm gonna do is move our main camera inside of the player, reset its position. So basically where we're looking at is where we are going to shoot. Parent that weapon to the main camera, so in the future when we have the camera controls, the weapon will shoot where we're looking again. And add in some geometry. First of all, a simple cube will do just fine. Let's do the lighting for this thing, and just so it looks better, auto-generate the light maps. There we go. Put that cube some distance in front of the player. 4 units is enough. And here we go. Now, if we start the game, we have a little bit of an issue. Hold on, let me try and trace this. Alright, so I took a little bit of a look around the code and I found the problem. We're not calling the onProcess event in the weapon script. It's a really dumb mistake, but fixing this now, things should work as need be, and as you can see I already tested it, so it does work. And here we go. I'm holding the input button and the action is being invoked every frame. We are making sure of that by debugging the logging the hit transform. So next up we're going to implement a constraint so we can control our hit or our actions, in general. So again, the same sort of thing. We're going to make a constraint folder, put that constraint in there. We're going to make an implementation folder, have all of our constraint implementations in there. And we are going to make a weapon RPM constraint, or we can just call it the weapon RPM, There we go. A weapon.module as usual, and a weapon constraint.i interface. And yeah, that's where this goes. We are going to constraint based on an RPM value. Let's keep this thing null for now. We're going to have an RPM value sort of thing going on over here. Let's start with something basic like 600 grams per minute, and let me try to remember that RPM formula that I use, and weapon constraint implementation, the value, and there we go, the delay. It's 60 divided by the value. Okay, So the idea here is that we're going to have the weapon constraint itself after every action for a set amount of time that is decided by the RPM value. And that delay is basically this, 60 divided by the value. 60 is, the seconds, the amount of seconds in a minute. The way we're going to be doing this, override the initialize, and listen to the process function event, process, there we go. And also we are going to be listening to the weapon action on perform. There we go, the weapon action. So the idea here is that we're going to be having a timer, a float timer, starting at 0 frames or 0 seconds basically. And the constraint is going to be active whenever the timer is bigger than 0. So you can see what we're going to be doing here. We're going to be setting the timer to that delay value on every single action, and then we're going to be processing that timer so it goes towards 0 using something like mathf.move towards timer 0f and time delta time. This will basically move the timer value towards 0 depending on the the normal time. So if we go ahead and add in that constraint over here, the RPM constraint, the weapon RPM, and try to use the weapon now. It's not going to be too apparent, but there we go. We're shooting a lot slower, or we're performing our actions a lot slower. It is a lot more apparent than I thought it would be. So if you have something like a weapon that fires at a really slow pace, like 100 rounds per minute, there we go, that's 100 rounds per minute. And if you have something really fast, like 1400 rounds per minute, there we go, it fires really fast, and you can just set that value, and it's gonna be working for every sort of weapon that you want. So next up, let's get some audio in here. The audio cues will be a nice feature to have. We're going to make a weapon action sound. What I usually like to do is to create a weapon sounds module that controls all of the weapon sounds. We can actually do that, yeah. Let's make a weapon sound, yeah. Or let's just call it the weapon audio. That's more weapon module. It's going to require a type of audio source, and we're going to be getting that audio source in the configuration method, basically. A audio source, we can just call it source, right? Override the configuration method, get the source, get component audio source, and voila. We can also put this as one of the the generic fields inside of the weapon script, so we can access it from any other module. Let's call it a weapon audio. There we go, get protected set. And same as here, basically, audio equals, should put this in a little helper function, something like get processor, but for now this is sufficient. Weapon audio, and cast that as weapon audio. And the weapon action sound, back to this component, let's make it a module as usual. Let's give it a audio clip, effects. Let's just call it clip. We're gonna override the initialize function, listen to the action on perform, and we're gonna do weapon.audio.source.play one shot clip. There we go. We can add these new modules then here. An audio module, a weapon audio, and then inside of the action we can have something like an audio module as well, a weapon action sound. Let's just call it sound, sure, no problem. We are going to need a sound effect. So I'm just gonna go copy one from the showcase project over here. Where did I keep those instances? Scar H, sounds, shot. There we go. Let's just take both of them, make a miscellaneous folder for now, and just drop them in there. There we go. The audio has an audio source. The sound will have the clip, Scar H shot, and now whenever we perform the action of the weapon, you'll hear audio feedback. And this will be good to showcase the RPM. 1200 will be sounding really crazy. Really crazy. And 200 really slow. Perfect. So you can consider this sort of like a beginning of how to do this modular weapon system. We'll sort of go on and build on this, add in more modules for animations, modules for procedural motion. You can just go crazy with this system, add in a lot of stuff. And the lovely thing about this is that it's very extendable, of course. So you can, like for example, this raycast. Think of maybe you have like a weapon that fires 3 shots at a time. So you have these 3 raycasts, and they're like offset a little bit. So I don't know, how can I offset these? Like 0.2. Yep, that will work. And then make these minus 0.2s, and this is 0.2, and this is minus 0.2. And let's give them a little bit of a visual representation. Let's make these, oh, did I type that? I meant 0.2 and negative 0.2. So there we go. If you have like a weapon that fires 3 shots on every action, you can just add in 3 extra raycasts on the weapon. And you can see over here, we should get 3 hits on, there we go, 3 hits from each raycast. And we're gonna, in the future, we're gonna have a hit module that will deal with everything that we hit. If it's damageable, it's gonna allow us to do damage to it. If we have effects on the weapon like bullet holes and bullet hit effects and stuff like that, the idea is to just modularize this thing as much as possible, so you can just mix and create and just compose any sort of weapon that you want to make. I hope you learned something in this tutorial. I'm really sorry if it's a little bit hard to follow. This is sort of my first tutorial, first time making this. Hopefully it will get better and better in the future. And thank you very much for following.